Basically, the project starts as two interconnected boxes. We can press the transmit button over here and it's received over here. We can send red and green lights, and we can send red and green lights back. And in its simplest form, we basically ask students to investigate how the boxes work and then figure out a way to send a message. Okay, what kids then tend to do is come up with simple coding schemes such as 1 press for an A, 2 for a B, and 3 for a C. So even kids at Key Stage 2 get simple ideas like that. What some then tend to go on and do is find out about Morse code and use ideas like that. So we might use green for a dot and red for a dash. So we might send S, O, S. And then they can send stuff in Morse. And then some kids will go on and find particular combinations. So maybe we represent a letter A by a red, green, red, and a letter B by a red, red, green, and different combinations. What we then do is get all the kids who've got all their own different coding schemes to mix up and try and send messages between them. Clearly, with lots of different coding schemes, it all goes pear-shaped. What we then do is implement a simplified 6-bit ASCII-like code, where each letter of the alphabet is represented by 6 binary digits. The binary digits are represented by red lights for 0 and green lights for a 1. So depending upon the level, we either just think as an A, being 3 reds followed by 3 reds, we read the column and then the row, or if we're teaching where binary is involved, we think of maybe the letter B being 0, 0, 0, 0, 0, 1. We then get the children to work out how to send a message such as hello, where we look at the letter H first of all in the grid, find our H here. To send a H, it's red, 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 3 zeros, 1, 1, 1, 3 greens. So we would send a H by red, 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 green, green, green. At the receiving end, children have the same code and therefore can decode the letter and realise that they've just received a letter H. Up to now, the children have been working closely with both boxes physically near each other, with a group on the sending and a group on the receiving end. We then replace the wire by a much longer piece of wire and separate the sender and receiver so that it's more difficult for them to communicate other than using the boxes. We then give them a whole word to send. Clearly, they can represent each letter, and this is done with relative ease, but when things go wrong, they've got no way to recover. In fact, they don't really know how to start the communication, who's sending, who's receiving, what to do if it goes horribly wrong and they lose track, or how to say that something went wrong and they didn't get it. What's interesting at this point is to listen to the communication that happens between the two ends out of band, i.e. the, okay, I'm ready. Oh, did you get that? Oh, sorry, ignore that, it all went wrong. Oh, can you send me that one again? Oh, I got that letter, okay. It's these messages which we get the kids then to think about. Pulling the children together to think about what extra messages they had to send to make the communications link works leads us to discussing how about sending those messages over the link using some of the unused characters. We then expose the final set of commands which can be seen here starting with 111, which are our control signals: start, end, restart, error or knack, and OK or ACK. And with the simple set of commands, we can send a start message and then we get an OK, so we've established the connection. We send each character and we get an OK or an ACK, or a knack back if it didn't work. And when we finish the conversation, we can send an end signal. And if it all goes horribly wrong, we can send a restart. So we typically see people then sending a letter such as an A, which is 6 reds or 6 zeros, and then the receiving end acknowledging that with an OK back. Oh, wrong ones, with an OK back, which is 6 screens. And then they can build a reliable communication system. In fact, what the kids have just invented, really without much direction from us, is TCP.